I just want to do a quick video here on fixed displacement gear pumps, and I just want to talk a little bit about how you can identify the direction of rotation and for a unidirectional pump like this one. I've got just for an example of a general pump, I've got a sort of a heavy duty Hydrico cast iron housing pump off of probably some mobile equipment application. And just looking at it, and of course the first thing I notice here is that the two ports on the pump are of course different sizes. I got a small port and we've got a larger port here, and of course the intake or suction side port will be the larger one. The pump, you always want a pump to be able to draw in more oil than it can ever pump away, because of course the hydraulic oil it's pumping also does the cooling and lubrication of the internal components. So suction port is identified as the larger port, and smaller ports to discharge. That tells me I've got a unidirectional pump. I guess there's some potential for this to be a unidirectional motor, but I'll address hydraulic motors in another video. So for this one, if I've got a pump and I've got two different size ports, it's a unidirectional gear pump. And if I wanted to determine which way it rotates, if I can see the gears in the suction or inlet port as I can on this one, all I need to do is rotate the shaft, and what I should see in there, of course, is gears separating. I should see the teeth actually separating. I'm trying counterclockwise and counterclockwise. I see the teeth of the gears meshing together. If I go clockwise, I see gear teeth coming apart. So I'm referencing the shaft direction facing the end of the shaft. When I go clockwise on this one, I see the gear teeth coming apart on the suction side, which means when the gear teeth separate, that's what's going to draw oil in. And I'm sure there's lots of animations on the internet that can reinforce how that works. I've got this little mock-up pump here that helps reinforce that concept. If I turn the shaft here to get the oil pumping, now I can see when the oil's pumping in the proper direction. I can watch the gear teeth turning in through this plastic cover that's been added here. And here's the reservoir, and of course this is the suction side, which connects here. And as the gear teeth come apart, of course it makes a space that didn't exist before the teeth separate. So when the teeth separate, that new space exists, and oil is then drawn in under the vacuum, and it's carried here between adjacent spur gear teeth, both individual gears around the outside of the gears. It doesn't go through where they're meshing together, because spur gears fit so tightly there isn't really room for oil to go this way. So the oil is going around the outside between adjacent teeth, and then when the teeth mesh together on this side, there's of course no space for that oil to occupy anymore. So with the space getting deleted, the oil then has to leave the discharge port, and that's where you can see it going through this clear line. So understanding the direction of rotation and how the gear pump works will let you understand that when you look inside the suction port, if you can see the teeth, the proper way they should be turning is to be separating. So if I grab another gear pump off the shelf here, just grab one random. Again, I've got a smaller port for the discharge, larger port for the suction side. And I'm just going to look in there and see if I can get some light on that. And I can see the teeth, and when I turn it, it's counterclockwise. Of course, counterclockwise, the teeth are meshing together. So this pump has been built for clockwise rotation. When I turn the shaft clockwise, I see the teeth unmeshing in the suction side, which is going to draw oil in. If I look in the discharge side, I'll see the teeth meshing together. But I usually go for the suction side just because it's bigger and usually easier to see the gears in there. And I've got one of these heavy-duty cast iron pumps apart here as well. And just looking at the parts and how this particular one would be assembled. Some pumps are convertible from clockwise to counterclockwise and vice versa, and this pump's not going back into service because it's completely worn out inside and all the parts are in need of attention. But just to look at it as an example of how the rotation would be determined on a convertible pump, or how it could be changed, this one's a good example. What I notice on this pump is on the mounting flange end of the housing, good quality pump with anti-friction bearings in it, but I also see there's a plug in here. It kind of looks like a bearing ball sort of in a sleeve pushed or pressed into this port, and it's able to be pulled out of there with a tool and put into this port. So this tells me I've got a convertible pump. And some of them it's a pipe plug, some of them there's different methods of blocking one of those ports or the other. But the idea of that plug is to keep high pressure out of the pocket under the bearings. Both of these drillings here in this part of the housing go down into that pocket, which is actually behind both of these bearings to lubricate them. But you can't have high pressure down there because, of course, our lip type seal for the shaft that's going to go through there can't hold back thousands of pounds per square inch of system pressure. So when the shaft goes through there, there's got to be a plug that keeps high pressure out of that pocket. But we do want suction side oil or low pressure to be able to get into that pocket so it can provide lubrication to these bearings and the surface where the shaft runs inside that lip type seal. So the seal can't hold back thousands of psi, so that's the logic of that plug. So on this pump you may find the plug on the other side, and that's going to determine ultimately what the rotation is of the pump. So on this one, and it's easier if one dowel comes with each side of the housing. If you didn't mark it when you took it apart, you could, if you got lucky, your dowels would force you to put it back in the right orientation. On this one, we've got both dowels in one housing, so we got kind of a 50-50 shot to get this right at installation. And so if there's no discernible markings, we'd have to look at that plug. So that plug is going to have to be on the side where the small port is, because that's the discharge side. So that tells me this housing goes, okay, the plug is here, so the plug is going to be here. The housing has to go this way, which tells me now that my driven gear, the shaft that's going to put power into the pump, is going to go on this side, and my idler gear, the gear on the other side, is going to go in this housing, so, or that side of the housing. And then I've got these two plates on this pump, thrust plates, sometimes called side plates or wear plates or pressure plates. They've got these high pressure seals on them, and I've got to get the orientation of those correct as well. Sometimes we'll call them bat wing seals just because of the shape of them, but they're basically just an O-ring and a backup ring kind of cut and formed into a high pressure seal and then a harder backup ring behind it. See a lot of O-rings and backup rings. This is just kind of another form of that. So on this particular pump, the two plates are also identical to each other, but we got 4 different ways we can install them. 1, 2, 3, 4. And of course, what we need to remember is we do not want these soft parts against the gears. If the gears were against the soft seals, of course, a couple revolutions are just going to chew those up and spit them through the system. So we know the high pressure sealing needs to go down for the first plate that's going to go in. Needs to go down against the gear housing, and the high pressure seals again have to be towards the smaller port, which is going to be the discharge port on the pressure side of the pump. So I've got the seal down and inside, and of course there's these pockets which, if you're familiar with different pump brands, may also help you with the orientation. So I've got that plate in right, and then again I know my driven gear needs to go in this side because I've figured out where the high pressure plug is on the other part of the housing. My idler gear is going in here, and then this last plate, of course, I want to have the seals up now because again I don't want the soft parts against the turning gears. That's going to damage the gears. And of course these plates are in really rough condition. So these wouldn't be going back into service under any circumstances, but they would sit like that, and the gears actually run against, in this case, the brass surface of the thrust plate or wear plate. And sometimes these are aluminum, sometimes they're steel with some kind of Teflon sprayed onto them, or different types of softer materials than the gears themselves. So got all those pieces on, and of course I've already figured out the orientation of the second part of the housing here, and I make sure I don't knock the bearings in. I'm lining up the shaft carefully and using the bolt holes as an indicator of where the alignment is for that. So all I'm covering again in this video is just the orientation of the parts. As far as reusability or condition of the analysis of the parts, or remanufacturing a pump like this, changing bearings or seals, I wasn't intending to cover any of that with this video, but that's, if you did take apart a pump for inspection and you're putting it back together and you're confused about the markings, you can see on this one I intentionally took any markings off of it, so to force the issue of identifying the high pressure plug on one side of the mounting flange side housing, and comparing that to, again, the smaller port, which is discharge, larger port, which is the suction side. And now my pump's been assembled for its intended rotation. And again, if it needed to convert it to opposite rotation, we'd have to pull out that high pressure plug and move it to the other side. And we'd also have to turn our pressure plates or wear plates around, so no, actually they would stay in the same position, but we'd have to move our gears from one side to the other. So that's, hope that helps. If somebody's got any issues with that.